I should have asked, is there anybody who doesn't have a copy of the quiz? Let me start with that. So Manchin knows I do this weird quiz thing. I actually encourage you to mark your own, and that way you learn from your own mistakes. So, of course, when you finish a quiz, do you hand it in right away? No, you wait until it's marked, right? And Manchin even remembers, who's my favorite student, Manchin? Me! No, sorry, Manchin, you're not my... Ah, there you go. See, you remember this little dance. We haven't done one for a while. All right. I wrote here for each of the following, make sure that you defic for full marks. What does defic mean? That's my acronym that I use in Physics 11 and Physics 12 when I'm teaching as a starting point. It says list your data, find the formula, insert the numbers, crunch the answers. It's not a one-size-fits-all, end-all, be-all, but it gives you a hook to hang an approach on to start out with. In other words, when I read these questions, Mara, the first thing I ask is, what are they asking me to find? And it looks like they're asking me to find that. So I'm going to write down I equals question mark. Have I written something down? Say yes. Do I feel better? Am I more relaxed even though this is a quiz? I am. I've just learned over the years, if I write something down, my probability of getting this goes way up. Now I'm looking for numbers and units. I see a 48. You know what? That 48 must be voltage. And you'll notice I didn't actually say has a voltage of. I said draws. I did that on purpose to see if you can still figure it out from the units. You can't. It has a resistance of 15 ohms. Even if they hadn't said the word resistance, I know ohms is resistance. Also, as I'm reading this, I'm checking to make sure my units are nice ones that I like. I'm making sure any times are in seconds. I'm making sure that there's no kilo ohms or mega or anything like that. I'm looking for an equation that has a V, an I, and an R in it. There is one. I want the one that has the I by itself. Cleo, which equation has the I by itself?
V equals, I equals V over R.
I agree. Now, there is a way to do all these in your head, to derive these equations in your head through some simple algebra, and some of you may already be comfortable doing it. When you get to Physics 11, that's how I teach my kids. We don't memorize. I don't give them all three equations. I give them one, and we learn to derive them. It's a much better way. But the voltage is 48. R is 15. Can I do that in my head? If I divide by 3, it's going to be 16 over 5, which is going to be 1.4, 2.4? Am I way off? I'm way off, apparently. You guys are all looking at me weird. 48 divided by 50. Well, 15. 3 point something. Sorry, 3.2, not 2.4. Wow. Way off, Mr. Dewick. 3.2 amps. Now, if you get that, you get 2 marks. Here's how I give out the part marks, by the way. If you just write that, that gets you a half mark. If I see that you were able to identify the equation, that gets you a half mark. In other words, Quentin, you can pass this question. Are you your quiz here?
No.
Did you do it?
No.
Do you have a copy of it?
Yeah.
It's tucked away somewhere? Okay, just watch. That's fine. You can pass this question without actually getting the right answer. Then I give you half mark for the numbers and a half mark for the answer. Okay. Number 2. Quinn, what are they asking me to find in number 2?
How much power?
P equals question mark. And just by writing that, I've even looked at a certain square or 2 squares on my formula sheet, the ones that have the letter P in them. What's that 8?
Curve.
What's that 4?
Resistance.
Do I have an equation that has power and I and R in it? Did I give it to you or not?
Yeah.
I did? Which one is that one?
P equals I squared times R.
Okay. So it's going to be 8 squared times 4. Now, I've told you that you don't need a scientific calculator for this unit. Some of you might have the cheap, crappy ones. How do you do squared on a calculator that doesn't have a squared button? What's the other way to type 8 squared?
8 times 8.
Yeah, 8 times 8. So it's going to be 64 times 4, which is going to be 256. Jimmy, power is measured in watt. We miss Jimmy. There you go. If Jimmy watches this online, you got a shout out. Because he likes that joke. Same as before, by the way. So 2 marks, but half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. I really, especially if you have me for physics, I'm not as concerned with the answer as I am, Petco, concerned with the process. And so it's possible to pass tests and not have a single right answer as long as you started the setup. In fact, in Physics 12, we're often doing questions that are 8 or 9 steps long, and the likelihood of making a calculator mistake or a dumb mistake along the way is pretty large. So in Physics 12, each of my written questions is worth 7 marks, and a lot of kids, you'll get 6 out of 7 or 6.5 out of 7. Even if they got a totally wrong answer, they did all the physics right, and I want to weigh the physics more than the calculator typing. Gabe, what's number 3 want me to find? Okay. What have they given me? What's that 6.4 kW? What is it? I don't think it's kilowatts, but what is it? I'll give you a hint, Gabe. Of what? Okay, so I'm going to write this. Power equals 6.4 kilowatts. I don't like that. How do I change kilowatts to watts? And you'll notice I've been a bit lazy. This is something I do, Leah. If I'm fine with the units, I don't even bother writing the units. I make it just a mental, I've checked that off in my brain. But as soon as I see yucky units, Allie, I write that down to get my attention, because to me that stands out even more. Okay, kilowatts, how do I go from kilowatts to watts? It's something to do with 1,000. Do I times by 1,000 or divide by 1,000? Times by 1,000, I can do that in my head. That's going to be, is that 6,400 watts? I think, yes? Gabe, what's that, 32? So I'm looking for an equation that has V and P and I in it. There is one. Can you read it to me, Gabe? Yes. So it's going to be 6,400 divided by 32. 200? Yes? I can do math in my head. 200 volts. As before, Brooklyn, half mark, half mark, half mark, half mark. But if you got the right answer, I'll give you 2 out of 2. Okay, cool. Now we're getting into energy. I see A is asking how much energy. But just by seeing that, I've moved over to another box of equations, Brooklyn, on my yellow sheet. Yes? Okay. Brooklyn, my joy, what's A asking me to find? How many joules of? Energy. And energy, I think we used the letter E for. Yes? What's that 1,200? And so of... Okay, power, and my units are okay there. I'm good with watts, so I'm not even going to bother writing the unit. I'm good with that. What's that 8? What are the units next to the 8? So hours is a measure of what? But do I like my time in hours? No. So I'm going to write T equals 8 hours. How do I go from hours to... Well, first of all, what unit of time do we use in physics? It's the second. How do I go from hours to seconds? Brooklyn, is that on your sheet somewhere? I think I might have stuck it on there. I think it has something to do with a 3600, doesn't it? You're right. It's on there. Gabe, can you show her where it is if she can't find it? And by the way, I'm doing this on purpose so that you know on the test. Oh, it is on there. Yeah. What does it say? Read it to me, kiddo. So am I going to times by 3,600 or divide by 3,600 to go from hours to seconds? Times? Okay. 3680. Good gosh. 3,600. Throw that one in your head, Mr. Duick. Oh, maybe. If I times by 2, it's 7,200. Times by 2, is it 28,800? Nothing? Really? Okay. I thought that was pretty good. To times by 8, you times by 2, you times by 2, you times by 2. And I can times anything by 2 in my head. So I times by 2, double it again, and double it again, because 8 is 2 cubed. Brooklyn, my joy, I'm looking for an equation that has an E, a P, and a T in it, and I want the E by itself. Is there one? Oh, you go girl. Slow down. So it's going to be 1,200 times 28,000 800. How many joules of energy? Now, this is a computer. Computers use anywhere from 800 to 1400 watts. A high-end gaming system would probably use closer to 2000 watts because they draw more. A Chromebook would probably use closer to 400 or 500 watts. Your laptops don't use as much because we want them to be as energy efficient as possible. But I tried to make reasonable numbers. If you use a computer for 8 hours, how much energy is it going to use? That's going to be 1200 times 28,800. And I get 3, 4, 5, 6, and 4 zeros. Joules. If you got that, that gets you 2 out of 2. Otherwise, I would give you, again, a half mark, half mark, half mark, and a half mark. You can imagine if your parents received their energy bill, because BC Hydro doesn't charge for power, they charge for energy, and they had numbers that big, parents would freak out. You would freak out. And also those numbers are so big, it's tough to wrap your brain around them. So there's another unit for energy. It's not the physics unit of energy. The physics unit of energy is the joule. But the billing unit of energy is the kilowatt hour. So B says, convert your answer from A to kilowatt hours. Okay. How do I go to kilowatt hours? To get kilowatt hours, I take the number that they gave me, 3, 4, 5, 6, 1, 2, 3, 4. What does the yellow sheet say I need to do? Is it multiply or divide? And we have to keep that straight, huh? Yeah, and if you're not sure, kilowatt hours are meant to be smaller and easier understood, so that's how you also know to divide. And I divide by a 3, 6, and how many zeros? 5 or 4? Got to get that right. 1, 2, 3, 4, 5. Divided by 3, 6, 1, 2, 3, 4, 5. Kilowatt hours. If you got that 2 out of 2, this one is a bit trickier to use the defic. Now, if you got A wrong, but you put your number from A right there, and you divided it by a 3, a 6, and 5 zeros correctly, give yourself 2 out of 2 for this one. Even though you got it wrong, you did it perfectly fine. You just started with the wrong data point, but I'm not going to penalize you for getting A wrong by getting B wrong. If you did that, I'm giving you full marks there, okay? Otherwise, here, I would probably do something like, oh, heck, half mark if I saw that, half mark if I saw that number, and then 1 whole mark for the answer, because here my defic thing doesn't quite work as well. Is that okay, Amy? If BC Hydro charges 8 cents per kilowatt hour, how much does it cost? Okay. This is asking me to find cost. Did I give you a cost equation on your sheet? I did? Wow. Brooklyn, let's finish this off, you and I. What's the cost equation on your sheet? Brooklyn, my joy, how many kilowatt hours? Careful. There's a point there. Yep. And 0.08. And I think I've done this rant with you before. Part of our problem with conserving energy is we're too good at making energy cheap, because to leave this computer on for 8 hours costs you 77 cents, which isn't that much. If you said 0.0768, give yourself 1.5 out of 2. We don't say it cost you 76.8 cents, and you should know that by now. We stop at cents. We don't go money to 3 decimal places, okay? Well, if it's so cheap to leave the computer on, why do we tell you to shut the lights off when you leave? Why do we tell you to turn the heat down? Why do we tell you to try and save energy? Is it for the money? Well, I guess, Sarah, if you did that every day, it would add up. If you save 75 cents a day times 365 days, that comes to a couple of $100. But it's because we have a limited amount of energy that we can create. And every time we need more energy, most of the ways that we create energy are environmentally destructive. They increase greenhouse gases and they increase carbon. They're not great. So shut your lights off for the planet. Turn the computer off for the planet. One of the big ones is if you have a video game device, PlayStation or Xbox, Kids used to always pause the video games, and those things draw a lot of power. And then they would just leave them running all night so they could get back to it the next day and continue where they left off. And that's why now I think more and more video games have a save option so you can save it and power it down. They've thought of that. Little nerd trivia. Turn the page. Well done, Brooklyn. Mansion, what's A asking me to find? Number 5A. See, I got you paying attention now. I agree. Mansion, what's that for? What's that 60? You know what? I was going to also say, what's that 40? But I don't think I need it right now. I think there already is an equation that has a V and an I and a P. Can you read it to me, please?
V equals P.
Yep. The voltage running through this is going to be 60 divided by 4. This is going to have a 15-volt drop when the current goes through there. Is that right? Same as before, so 2 marks, half mark, half mark, half mark, half mark. Ah, Mansion, what's B want me to find?
Resistance.
Okay. Mansion, did I just write everything in part A? Say yes.
Yeah.
I'm not going to make you rewrite it. You can if you want to. But how can I find resistance? What equation could I use?
R equals V over I.
Now, the only way that I can do B is if I've done A first, because I need the voltage. So it's going to be the voltage, 15 divided by 4. Now, if you got A wrong, but you dropped your answer from A right there and you divided by 4, I will give you full marks for part B. 15 divided by 4, 16 divided by 4 would be 4, so 3.75 ohms. Oh, by the way, if you don't put units, I take a half mark off as well. I'm mean that way. Mansion, what's C want me to find?
Energy.
How do I find energy?
P times Q.
Did they tell me the power? I've scrolled down. What was it?
60.
Did they tell me the time?
Yeah.
What? Now this is weird because in A, they said 40 minutes. But what did they say in part C? So I'll use that time. I did that on purpose just to see you, read carefully. 20 what? I don't do physics with minutes. How do I convert that to seconds? So I think you're going to get 1,200, is that right? Seconds. So it's going to be 60 times 1,200. 6 times 12 is 72, and then I have 1, 2, 3 zeros. Is that right? 72,000 joules. 2 marks again, same as before. Half mark for that, half mark for that, half mark for that, half mark for the answer. If you went 60 times 20, if you forgot to do the conversion, I would take a half mark off and I would give you the frowning of a lifetime. Last page. A 120 volt source is connected to a 240 watt resistor. Find the current. Okay. Change colors, Mr. Dewick. I equals question mark. They've told me that we have 120 volts, and they've told me that the power is 240 watts. They haven't told me the resistance. Okay, I can figure out current from here. It's going to be P over V. It's going to be 240 over 120. Is the answer 2 amps? 2 marks for that. The resistance, now that I know the current, I think I can go R equals V over I. This is why I've been saying to you, Mansion, if you know 2 things, you know 4 things. If I know any 2 of power, resistance, current, and voltage, I can find the other 2. It's going to be V 120 over I 2. This is a 60 ohm resistor. Heat energy. Oh, energy. Energy is power times time. So that's going to be, did they tell me the power? They did. 240 times 20. Why can't I go times 20? Why is that wrong? Minutes. So I have to make that 1,200 seconds and plug that into there. So it's going to be 24 times 12. 12 times 12 is 144. Two of those, it's going to be 288. And then 3 zeros. Is that right? Is it 288 with 3 zeros? Jules? And then convert this answer to kilowatt hours. If I want to go to kilowatt hours, I take the energy in joules and I divide it by a 3, a 6. Quinn, how many zeros? Is it 5?
Yeah.
That was your cue, my friend. So it's going to be 288,000 divided by a 3, a 6, and 1, 2, 3, 4, 5 zeros. Do you get 0.08 kilowatt hours? Yes, no? Manchand is so eager, he's standing up already. Again, 2 marks. I didn't quite follow my DFIC approach because I could see you guys were getting a little squirrely and tired, but I would give you a half mark for listing your data, half mark for the equation, half mark for the numbers, half mark for the answer. But if you get the right answer, I do give you 2 out of 2. But there's plenty of part marks to go around. Can you give yourself a lovely score on this quiz out of 26? Don't hand it in yet, Manchand. Instead, if you need to come lawyer with me, now is the time. Feeling confident with your circuit solving. If you want to start working on the solving circuits homework and just tune me out, you can. But those of you that would like a little bit of a refresher, if you want to look at this practice circuits, Clio and others, we're going to do the first one together, maybe even the first 2 if you want. It's totally up to you. So let's do one together. What's number 1 asking me to find? What is the?
Power.
In which resistor? In the?
Circuit.
In which resistor? In the?
8.
You know what? It wants us to find the power down there. Okay?
Yeah.
I think to do that, we're going to have to find everything. So, key ideas we're going to keep in mind. You can even jot this down in the margin if you want to. We know V equals I times R, which also is R equals V over I, and I equals V over R. In other words, if I know any 2 of those, I can find the third one. And we're going to use power equals V times I. And at the tail end of last day's lesson on circuits, I gave you kind of a step-by-step approach. I said the first thing I do is I label downhill. I put 1 arrow there, but let's put a few more. That's downhill, downhill. It's always from the positive end of the battery to the negative. Which way do electrons flow, by the way? The opposite direction. Am I telling you a test question? Yes, I will give you a question on the test, and I'll say, draw in the correct direction of current, draw in the correct direction of electron flow. They're opposites. But it's much nicer to pretend the positives move because it makes the math easier. I've hopefully convinced you of that. All right. Did they tell me how many amps are leaving the battery? How many amps are right there?
2.985.
Why so yucky? Because I stole this from the internet, and when I ran the numbers, this is what I got. So do I know the current right there? 2.895 amps. So let's follow. Here the current splits up, and I don't know how it splits up. Some goes that way, some goes that way, but it rejoins. How many amps are going through this resistor? You're right. How many amps are going through there?
2.
Yes. So right now, let's write down I equals 2.985 amps. Yes? Do I know 2 things? I know 4 things. I also know how many volts and how much power I have there. So volts, it's going to be I times R. Now you can use your calculator. This number, well, you know what? This times 10, I think 2.985 times 10, isn't it going to be 29.85? Double check me if you want, but I'm pretty sure. Yes? Yeah. And power, this is going to be yucky. It's going to be V times I, so it's going to be 29.85. I told you it's just too tough to make these work out evenly, so I gave up after a while. Times 2.985 V times I, and you get a yucky power of 89.1. I'll call it 89.1 watts. If that was a light bulb, it would probably be labeled as 90 watts. So how many amps right there, Cleo?
2.985.
How many amps right here? Still the same. How many amps right here? Still the same. Ooh, how many amps going through this resistor?
2.8.
Yes. And now I can smile. I know two things. 2.985 amps. I can also tell you how many volts we lose going through that resistor. How will I figure that out? Read me that equation right there. Read me that equation right there.
V equals I times R.
Do I know I?
Yeah.
Do I know R? Okay, I know V then. It's going to be 2.985 times 12. Do I need to type 12.0? Will that make an actual difference in my answer, the 0.0? So I'm lazy. I tend to abbreviate. Here I have 35.82 volts. And just for giggles, let's find the power. Power is going to be V times I. That number times that number. I have no idea what that's going to be. Oh, I have this on my calculator, so if I hit times, it's going to use my answer button. 2.985. 106.9. Mr. Duke, how many decimal places should we go to? Usually 1, unless they give me more, so I'm going to use the 2.985 because they gave that to me to 3 decimal places, but otherwise I round off to 1. Okay. Do I know how many volts in here, how many volts in here, how many amps, how many amps? Say no, say no, say no. Okay, but I said first thing we do is we walk through with currents. You okay with that? Then we look for anywhere where there's 2 things. We did that here once we knew the current, and we did that here once we knew the current. Do I know 2 things there? Say no. Do I know 2 things there? Say no. Okay. And we ski. What was the skiing trick? We said that if you do a loop, whatever voltage you gain from here, you have to lose along the way. How many volts do I gain from the chairlift battery? How many volts is the battery?
80.
How many volts do I have to lose? Same answer.
80.
How many do I gain? 80. So I'm going to do a ski path. I'm going to do this one. Watch with your eyes. Is that always going downhill?
Yeah.
So that's a legal ski path. Here's what you aren't allowed to do, by the way. You're not allowed to do this one. Because now, right here, you started going back uphill. Without a chairlift, you can't ski uphill. So we're not going to have you suddenly start cross-countrying and going back up the hill. Okay, you're going to follow the markers. All right, so here's a ski path then. I'll leave this on there. You don't put this on yours. So if I follow this, I should lose how many volts grand total?
72.
No,
sorry. What?
How many volts do I have to lose?
80.
80. So you ready?
Yeah.
How many volts?
80.
How many volts do I lose here? Don't know. How many volts do I lose here?
Would I go 29 minus 80?
No. Just read me that number.
29.8.
That's how many volts you lose there. How many volts do I lose in this resistor?
35.82.
Now, you're asking, so what do I actually calculate? I think to figure out this one, if on my calculator I go 80, type in your calculator, 80, and then you minus this voltage, 28.95, sorry, 29.85, 29.85, and then you minus this second resistor voltage of 35.82, and hit equals. What'd you get?
Oh, I just went wrong.
Do it again. All right, we're starting with 80, and the 2 resistors that I do know the voltage drop is 29.85 and 35.82, and I'm minusing because when you go through a resistor, you lose voltage. You use up voltage. What do you get?
14.33.
That's how many volts must be in this resistor down here. This resistor down here has to be, what did you say it was?
14.3.
Hey, do I know two things in that resistor? Then I can find everything. What's the current in this resistor? It's going to be, I know R, I know V. How do I find current?
I equals
Yep.
I equals
V 14.33 over
over R.
8. So the current is 1.79125. If you wrote 1.79 or 1.8, I'm okay with that. But now, what did this question want me to find? Read me this first line right here. What is
What is the power?
dissipated in
In the 8
ohm?
ohm resistor.
Oh, that's this one? Do I know the voltage?
Yeah.
Do I know the current? Can I figure out the power?
Yeah.
Here's our final step. So we're going to take that 14.33 times 1.79125. Whew! How many watts of power is used up in that 8 ohm resistor in R4? If you wanted to give it a shortcut, I guess you could call it R4. You get 25.6686. Blah, blah. You know what? I'm going to call it 25.7 watts. All right, Mr. Duick's shortcut time. What did they want me to find?
Power.
That answer, specifically the power in there. Do I have numbers all over the place? What's the easy way to tell the marker that the final answer they're looking for is this one? Put a box around it like that. Do that. Then if I happen to look at yours, I'll go, oh, there it is. Okay. And in fact, if I'm marking your, if I gave this, this is probably a tougher question that I would ask on a test, but if I gave this, I would look for that number in a box and I would give you, 4 out of 4 or 3 out of 3. I wouldn't even look at the rest of the stuff because there's no way you could have fluked into that and got these wrong. Does that kind of jog on our memory?
Yeah.
I can do one more or I can turn you loose.
Everyone can do it.
Okay, folks. Anybody else want me to do one more? I can. Hang on to this handout. Don't lose it. On Friday, we'll do a couple of more practice ones. These are nasty, by the way. If you're wondering where these came from, the old Physics 12 provincial exam. Okay? Yeah. I'm taking you well beyond the Science 9 baby textbook because circuitry is cool. If you're finding this tough, you're normal. This is good stuff, though.